Hey, what's up? My name is Ben. We'll be working on time volume units, time volume theory, and time volume span, which is a theory I've been working on. It actually follows up on relativity and should explain how time in the universe works. Came about this theory as I was working on some development software, which is actually quite nifty. Okay. First one. And like quite a few. There we go. Yep, some other stuff. There we go. Here's one part. Okay. So basically, when you think of time, right, most people think of it as a 2D scale, like it just goes across, like, imagine a clock. A clock would go from 1 p.m. to 2 p.m. to 3 p.m. to 4 p.m. to 5 p.m., etc. But when you think about time, it's really more of a three-dimensional object when it's in relation to the cosmos. The thing is, time is actually affected by quite a lot of things. When it comes down to it, it's really just a measure of the rate of change from one state to the next, and it can be in any number of cycles, in any frequency, but it all boils down to basically a volume. It's a volume unit. Well, in my theory at least. You can imagine time as like a three-dimensional object. It would look something like this. Just a bunch of cubes and stuff. Now when you put it in relation to space, you can imagine a field where it's just a bunch of cubes. Now, as it's passing from state to state, it varies by things such as gravity, which will actually warp time-space because of the presence of mass. So it's actually pulling the units, it's pulling space and time itself closer to a more central point. For example, when you think of like a black holes actually stretch time-space so much that as it's crossing more and more distance towards a black hole, it's actually covering less and less space because the time units are being stretched so far apart that eventually even light itself won't be able to cross a single time unit. That when it gets to that unit, it's actually past, that's the event horizon where it keeps going and there's no return. Pretty much that could explain why black holes are black. So that's relative to what we see though. Like what we see. If you were relative to this object though, relative to your position going towards a black hole, it would actually be going faster and faster. And that part I can explain through velocity. Velocity now, how this affects time is, when you're moving at low velocity, it's just time is normal. It's like, tick, 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 tick. As it's going through high velocity, it's actually going through time units a lot faster. It's like tick, 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 tick. And an aspect of that is the faster you're going, relative to the object, you're actually, time for you is going slower, but relative to what's observing, as we observe it, it's actually going much faster. So something moving at very high speed in space is actually going through time a lot faster. Time is elapsing faster for it. However, relative to its position, it's actually growing older a lot slower. Time is elapsing a lot slower. And that's just because the time span for it is basically being stretched over more time units. So as it's increasing for our perspective, it's actually increasing from its perspective. Okay? So let's move on to writing the formula to explain it. Okay. If you were to write time as a formula, even though it couldn't be solved by Einstein's equation, because he had basically theorized that space-time had to be infinite. But in this aspect, it doesn't have to be infinite. Just time itself is actually finite, but space itself, you just have to separate it, and then it works. Okay, so we have time, volume theory. It's based on relativity. By Albert Einstein. I'm not sure, is that E? Sorry, Mr. Einstein, if got it. And this one, though, the volume theory, is by me, Benjamin Dean. Okay, let's see. Now, we had to take into account how it all works. Imagine time, which is finite, over the universe, which is infinite, space, which is a container. Okay, now all of this equals and I'll have to explain these real quick, but I can write them out. Plus, minus 1 time unit for your observation time span. Go over variables, bars. Mass density, mass velocity, plus gravity. And then it's plus or minus 1 time unit for whatever you're watching. Observation time span. So basically, this all actually ties together to relativity. Okay, let's see. This would be something like, this would be basically the whole universe. This would be like the whole universe right here. Okay. Now, we have time, which is okay. This is basically personal time span. This is the time span of your life or whatever you're watching, for however long you watch it. This is the objective span, which is however much time you spend watching something. This would be time relative to velocity of an object. This would be time relative to the density of said object, which actually does affect its velocity and its gravitational fields aspects in basically in the same, etc., or not, in conjunction with one another, and gravitational fields, which is actually the last part. So it'll be something like this. There's your time span, right? Okay, this is your observation perspective. Okay, and this is velocity. Okay, because as you go faster and faster, it's actually getting out of that. This is basically mass velocity. Okay, then this would be mass density. Okay, then this would be gravitational fields. And this would be watched objects. Perspective. And with that all together, you have time. And basically, this would cover all of it in relation to how it works with the addition of redshifts. Because once you take into account that space itself was not expanding, but in fact it probably could be, where is it? It probably could be static. Now, how do you ask, or you may be asking, how's that possible? Because space is supposed to be expanding, right? Space itself actually expands and contracts. However, in relation to time, as we know it, Einstein couldn't really cover that part of how space was expanding. In his theory, he didn't like the idea of time-space, being finite. And in his era, they didn't really have the tools we have in modern day, like VLRT, stuff like that to measure distances in space. How we measure it these days is the luminosity level from type 1A supernovas, which will give us a redshift measurement. Basically, as a galaxy or Supernovas moving further away, it'll appear red on the wavelength, on the light spectrum. If it's moving closer, it'll appear blue. Now, if you take into account that we're measuring it currently in a straight line because we're measuring it by luminosity levels, it might appear as though we're actually, space is expanding. But if you take into account that space is curved, you know, because of gravity and stuff like that, and light has to go through an arc, it's not going in a straight line. So when you factor that in, instead of space being a straight line, it's curved, and it might appear as though space is expanding when it's in fact probably static. Static with dynamic objects which move within it. Now when you factor that in, that's basically time itself. I believe that's why Mr. Einstein was stuck. You have to separate time and space for time to be able to be explained. I think that's a big factor of it. Anyhow, my name is Ben, and I appreciate your time. Thank you.